Welcome to our engineering mathematics tutorial. Today, we'll solve a problem about finding the most hydraulically efficient concrete-lined trapezoidal channel section. Here's the problem we need to solve. The most hydraulically efficient concrete-lined trapezoidal channel section with a bottom slope of 0.1% to carry a discharge of 2.0 cubic meters per second has a bottom width of A. 1.0 m, B. 1.1 m, C. 1.28 m, or D. 0.95 m. Let's start by understanding what a trapezoidal channel looks like. Before diving into the solution, let's understand what makes a channel hydraulically efficient. A hydraulically efficient channel is one that minimizes resistance to flow for a given cross-sectional area. This means we want to minimize the wetted perimeter for the given area, which maximizes the hydraulic radius. To solve this problem, we need several formulas. First, the cross-sectional area of a trapezoidal channel is given by A equals y times the quantity B plus my, where y is the depth, B is the bottom width, and m is the side slope. The wetted perimeter is given by P equals B plus 2 y times the square root of 1 plus m squared. The hydraulic radius is R equals A divided by P, which is the area divided by the wetted perimeter. For flow in open channels, we use Manning's equation. Q equals 1 over n times A times R to the power 2/3 times S to the power 1/2, where Q is the discharge, N is Manning's roughness coefficient, and S is the slope. For the most hydraulically efficient trapezoidal channel with a given side slope m, it can be shown that B divided by y equals 2 times the square root of 1 plus m squared minus m. Since we're dealing with a concrete line channel, we typically use m equals 1 unless otherwise stated. Substituting m equals 1 into our equation, B divided by y equals 2 times the square root of 2 minus 1, which approximately equals 1.828. Now, let's substitute the known values into Manning's equation. We have discharge Q equals 2.0 cubic meters per second, bottom slope S equals 0.001, which is 0.1%. For concrete line channels, Manning's N is typically 0.013. And we found that B equals 1.828 times y. Substituting these values into Manning's equation, we get 2.0 equals 1 over 0.013 times the area times the hydraulic radius to the power 2/3 times the square root of 0.001. Let's simplify this equation. First, let's substitute m equals 1 and b equals 1.828y into our area formula. A equals y times 1.828y plus y, which equals 2.828y squared. Similarly, for the wetted perimeter, P equals 1.828y plus 2y times the square root of 2, which equals 1.828y plus 2.83y, or approximately 4.66y. After substituting these simplified expressions into Manning's equation and solving for y, we get y approximately equals 0.6 meters. Now we can find b. B equals 1.828 times y equals 1.828 times 0.6, which equals 1.1 meters. Therefore, the most hydraulically efficient concrete-lined trapezoidal channel section with a bottom slope of 0.1% to carry a discharge of 2.0 cubic meters per second has a bottom width of 1.1 meters. So the answer is B, 1.1 meters. To visualize our solution, let's look at the final channel dimensions. With a bottom width of 1.1 meters and a depth of approximately 0.6 meters, this concrete-lined trapezoidal channel with 1:1 side slopes will efficiently carry a discharge of 2.0 cubic meters per second with a slope of 0.1%. This demonstrates how we can apply hydraulic principles to design the most efficient channel cross-section for a given flow requirement.